Well, have you figured out what the C does to the quadratic function? It just moves it up or down. The correct word is it translates it. And so when I put a 5 here for C, it's going to translate it 5 from the origin. Now, what if I put a -5? Is it going to make it go upside down? No, it's just going to move it 5 down from the origin. So that's all it does. Now, you might have said, well, it makes it wider or narrower. No, it doesn't. It's just that in this case, you see the blue parabola, much more of it than the red. But if you were to be able to cut and paste, you would see that it is the same width right here around the vertex. They are the same width. All right, so now how do we draw these? We're going to start here. We're going to always start at the end, just like we do with linear functions. So I'm going to start with the +3, and I'm going to go right here. And then I'm going to put a number in there. Now, the domain is all real numbers. I can put any number in the world in there, but I like to put easy numbers in there. So I'm going to put a 1 in there. What's 1 squared? Well, 1 plus 3 is 4. So when I put a 1 in there, I get a 4. And then I mirror image it over to the other side. And so these two dots need to be equal distance from the vertex. Let me put another number in there. I'm going to put a 2 in there. So what's 2 squared? 4 plus 3 is 7. So if I put a 2 in there, I get a 7. So I'm going to go right here. And again, I'm going to mirror image it. And then I'm going to do my best to connect these dots. I'm also going to do my best to try to make it look more of a U than a V. That's kind of hard freehand. All right, let's look at another one. This one, again, we're always going to start here at the C value. And so it's -1. So I'm going to go down 1 from the 0. So right here. And then I'm just going to put a 1 in here. What's 1 squared? Oh, remember, we do the squared before we do the multiplication. So 1 squared is 1. Then times 2 was 2. Minus 1 is 1. So when I put a 1 in, I got a 1 out. And then I'm going to go over to the other side of this axis of symmetry. Remember, your parabola has to be symmetrical. Let's go ahead and put a 2 in there. So 2 squared is 4, and then times 2 is 8, minus 1 is 7. So when I put a 2 in there, I get a 7. So that's here. When you're drawing something on paper, it is always nice to have 5 dots so that you can kind of get a really good grasp of the width. And I am not very good at drawing these. Oh, there we go. That was not great. Let's see if I can try that one more time. Here we go. That's a little bit better. All right, let's see what happens when we have fractions. All right, again, we're going to start at the back. So we're going to go to that -4, which is down right here, 4 from the origin. And then instead of putting a 1 in there, because if I put a 1 in there, I'm going to get a fraction -4, and I don't want to do that. So I always use the denominator. So I'm going to use 3 for x. So remember, we're going to do the squared first. We do the exponent before the multiplication. So 3 squared is 9. What's 1/3 of 9? 3. And now I have 3 minus 4 is a -1. So when I put a 3 in there, I got a -1. And then I'm going to just go right here, equal distance on either side. And I just for sake of time, I'm going to just use the 3 points here. All right, there we go. All right, let's do one more. Where am I going to start? Well, if you said the +5, you're right. So I'm going to just move it up 5. And then this time it's -1/2, so I'm expecting this to go down. Am I going to put a 1 in there? Nope. I'm going to use the denominator of 2. Remember, do the x squared first. So 2 squared is a 4. Half of 4 is 2, but it's negative, so -2. -2 plus 5 is a 3. So when I put a 2 in there, I got a 3 out. Then I'm going to go equal distance over here, just like that. And again, just for time, I'm just going to use these 3 points. Try that again. Trying to make it, again, as U-shape as possible, because there's a different graph that does a V. All right, you try it.